When geography, history, and chemistry are locked in separate textbooks, students struggle to see the connections required to solve real-world problems like climate change or industrial decay. Reconnecting these subjects often begins by looking at a specific local detail that usually goes unnoticed during a daily commute. This model of a 5-centimeter gauge train sits right next to Taichung Industrial High School in the Gongshui community. Most students pass it every day, unaware that these abandoned tracks once anchored a massive international sugar trade. This framework, titled A Sweet Return, is an educational experiment by teacher Kang-miao. It overlays geography, history, and chemical engineering to meet the UN's Sustainable Development Goals, or SDGs, a global blueprint for protecting the planet. Over 6 lessons, the curriculum transforms these local ruins into a dataset for an immersive investigation. The investigation starts with a digital mystery called Grandpa's Secret. Using a timed point system, students enter a narrative-driven environment to recover fragments of the town's industrial past. In the first chapter, students use Google Street View alongside century-old maps, identifying the exact locations of former sugar mills and light rail remnants. In the next stage, the challenge shifts from spatial navigation to data analysis. Students must calculate changes in sugarcane cultivation area and interpret international export statistics to unlock the next part of the story. To understand the industrialization of the sugar trade, students interview a generative AI persona of Nitobe Inazo, the historical figure who modernized Taiwan's sugar industry. To prevent AI hallucinations, where the model generates false information, the teacher preloaded the AI with verified primary sources and chemical facts. This ensures the digital dialogue remains historically and scientifically accurate. This back-end dashboard allows the teacher to monitor every conversation in real time, checking for student engagement and identifying specific points where a group might be stuck. By the end of the digital phase, students have successfully analyzed light rail distribution, calculated trade volumes, and extracted industrial patterns from a primary source-backed AI. While the digital investigation uncovers the history of the trade, it also reveals a physical problem, the massive amount of waste generated by sugar production. This diagram introduces the circular economy, a production model keeping resources in a closed-loop system to eliminate waste. Here, bagasse, the fibrous waste from crushing sugarcane, is no longer burned, but becomes the primary input for paper pulp. Students take this raw bagasse into the lab. They run experiments using different concentrations of bleach and binding agents to see how chemical variables change the strength and color of the resulting paper. This process creates a physical carbon sink. A carbon sink is anything that absorbs more carbon from the atmosphere than it releases. By turning plants into paper, the CO2 absorbed during growth is trapped in the fiber instead of escaping back into the air. While conducting the experiment, students use shared lab logs to record their variables and write about the long-term impact of chemical additives on the ecosystem. The lab exercise transforms the abstract concepts of carbon cycles and waste management into a verifiable chemical process. The curriculum concludes when the raw bagasse fibers are dried and shaped into handcrafted bookmarks, turning the students' research into a physical product. All lab results, photos, and final reflections are posted to this digital Padlet wall, allowing the entire class to compare their findings and peer review each other's work. This grading rubric shows that the assessment isn't a test score. Grades are based on the precision of the experimental record, the quality of team collaboration, and the depth of the students' connection to their hometown's industrial environment. This summary map shows how the curriculum moves from historical investigation through data analysis and finally into physical production. By utilizing AI tools and cloud collaboration to reclaim a forgotten piece of local history, students finish the course with a specific understanding of how to calculate carbon, manage resources, and address industrial waste. This is the tangible result of a classroom that treats history as a resource and science as a solution.